Hey everybody, so today we are looking at 4.2 solve inequalities using multiplication and division. Okay, in our last lesson we started inequalities. We learned how to kind of read them and graph them. So before we get into this, I want you guys to try a quick little warm-up dealing with what we learned yesterday, and then we'll get into the new stuff today. Okay, so go ahead and take a moment and copy down these first couple problems. I'll scroll down. Well, actually, I'll scroll down now so you can get them all. Right. So yeah, just directions, write an inequality represented by the graph. They want you to tell what does this graph represent? What inequality? Okay, when you guys get to 3 and 4, they want you to solve and then graph. Draw yourself a little number graph, or number line, and then graph your inequality. So go ahead and try out this warm up. Okay, so on number 1 here, if you guys remember when we write out an inequality, just, we're going to use the generic variable x if we're not told otherwise. So I'm going to use x. Looks like we're dealing with -4. The big question is what inequality goes in this spot? Well, here's two things I noticed. I noticed that our arrow is pointing to the left, and I noticed that our dot is filled in. All right, so quick little reminder, this would be a greater than, this is less than, this is greater than or equal to, less than or equal to. Okay, I know that when a arrow is pointing to the left, that's where the numbers are getting smaller on my graph, where they're getting less than. All right, so I know I'm using a less than sign. That filled in circle, though, means that I'm using an equal to symbol. All right, so this is the graph of x is less than or equal to -4. All right. On number 2, same idea. I'm going to use x. Looks like we're at +10 here. Right. This time we have an arrow going to the right where the numbers are getting greater than, and we have an open circle, which means it's not a greater than or equal to, just greater than. All right. So x is greater than 10. All right, cool. So down to these here. First things first, we have a little bit of solving that we need to do. So let's go ahead and do it on number 3 here. We just have one number to get rid of. A 4 is being added, so I'm going to subtract it from both sides. Okay, subtracting a 4 from both sides, we get rid of them. We have an x here. Okay, no reason to flip the inequality when we subtract the number. I'm pointing that out because today the point of this lesson is when do we flip the inequality? We'll get to it. On the right, looks like we have a 1. Okay, so x is less than 1. So when I go to my draw my graph, I like to just put that number in the center and then surround it by a few. So 1, 2, 3, 1, and then 0, -1. All right, first things first, it's not an equal to symbol underneath it, so I know I have an open circle on my graph. Since it's less than, I know my arrow is pointing to the left where all of the numbers are getting less than. All right. Number 4, we're solving for y on this one. That's fine. I just want to point out again, we're just worried about this -8, not this one over here. We just want to get the variable by itself. So we'll add 8 to both sides. Okay, looks like we get a 0 on the left. No reason to flip the inequality when we add numbers to both sides. And we have a y on the right. Okay, here's the big thing. When we read our inequalities, we want our variable to be on the left and our number to be on the right. So I'm going to flip-flop this, put y on the left and 0 on the right. But if I do that, I have to also flip-flop my inequality. So this less than or equal to symbol turns into a greater than or equal to. All right, so I'm going to put 0 here, surrounded by a few numbers. All right, looks like we have an equal to symbol, so solid dot on our graph. Greater than is to the right where all the numbers are getting greater than, bigger. Okay, so there's a nice little reminder on what we did yesterday. Today's a continuation of it, but multiplication or division is going to be thrown in, and you'll see what that does. Okay, so real quick, go ahead and get this title at the top of your paper, and you can go ahead and copy down this first example. All right, so they want us to solve and graph. All right, first thing, pretty simple problem. I noticed that we have our variable is being divided by a number, so we're going to undo that with multiplication like we always would. So I'm going to multiply both sides by 4. All right, so they're canceling here. All right, when I multiply both sides by +4, no reason to flip the inequality, staying the same. Over on the right, looks like we have 20. All right, so let's go ahead and draw ourselves a graph. Okay, again, I'm just going to put that number in the center surrounded by some. By the way, it doesn't really matter. I could do 21, 22. Sometimes you'll see in the book they'll do like 25, 30, just to kind of show you, and then this would be what, 15, 10, right? However you want to do this, it's completely up to you. I don't really mind. Normally you'll be provided, like if it's a test, you'll be provided with a graph. Okay, so yeah, we have a no equal to. So I know we have an open circle here. It's less than, and that means we're pointing to the left. So really not a lot different on this one. Let's try the next one. All right, so on this one, same directions. Go ahead and copy this here and also get this little note off to the right. Alrighty, so I guess we'll read this first. Multiply or divide by a negative, flip inequality. All right, I'm sure you've seen this stuff before, but yes, if you ever multiply or divide both sides of the equation by a negative number, you will flip the inequality. Okay, so on this problem, we go to solve for x. It's just like the last problem, right? It's being divided by a number, so to undo it, we will multiply by that number, both sides. Okay, but here's the big thing. I just multiply both sides by a negative number. That means I'm going to flip my inequality. And I always suggest doing that first. It's really easy to forget if you don't. So this less than sign is going to turn into a greater than sign. Okay, and again, that was because I multiplied by a negative number. On the last problem, I multiplied by a positive number. That's why I didn't flip that one. All right, so those are gone. I got x is greater than, looks like negative 42. All right, and this looks weird to me. I don't like this. I guess that's a little better. Okay, so now we can graph this thing real quick. So go ahead and draw yourself a little graph. Okay, I'm going to put that negative 42 in the center. Okay, here's something to look out for. Here's what you might be tempted to do. You might be tempted to go, oh, negative 42, negative 43, negative 44. But no, if you guys notice, those numbers, that's getting smaller. Okay, remember when your number is negative, as it gets smaller, it becomes a bigger negative number. So this would be negative 43. This would be negative 44. Okay, and as it gets larger, this would be negative 41, negative 40. Okay, so be careful when you get a negative number on your graph. It's really easy to kind of mess up which way the less than or the greater the numbers are. All right, so again, open circle, no equal to symbol underneath it. It's greater than, we know that's numbers going to the right. Okay, so let's try another one here. All right, go ahead and copy this quick inequality. All right, so yep, it looks like we have our variable being multiplied by a number. So to get rid of it, we will divide by that number, both sides. Okay, here's what I just noticed. We just divided both sides by a negative number. Okay, that's one of the rules where we have to change our inequality and flip it so a greater than or equal to turns into a less than or equal to. All right, so over on the left here, it looks like we're getting a negative 8. On the right, we have x. Okay, but now we want to get this thing into the proper, I guess, form. We want our variable to always be on the left, our number to be on the right. So that means we have to then again flip our inequality. Okay, so there is our final one. And by the way, usually I like it when you put boxes around it. I've been forgetting to do that. All right, so on our graph, we have negative 8 here. Okay, just remember, if I'm getting numbers larger than negative 8, that'd be negative 7, negative 6, making my way to 0 and then into the positives, right? Over here, smaller negative, or I guess a bigger negative is maybe the way of thinking of it, negative 9, negative 10. Okay, equal to symbol, so close dot, greater than goes to the right. Okay, now I'm going to have you guys go ahead and try a couple of these on your own. Go ahead and try these problems out. Okay, make sure you graph them as well. All right, so on number 1 here, we have a 5 being multiplied by x, so we'll undo it by dividing by 5. Okay, here's the question. Do we flip our inequality? We divided by a number, right? Does that mean we flip the inequality? No. All right, we flip the inequality when we divide or multiply by a negative number. Okay, not negative, not flipping. Okay, so this is still staying greater than or equal to. So it looks like we got x is greater than or equal to 9. All right. And yeah, the rest of this, I mean, the graphs is hopefully becoming second nature. We got a 9, 10, 11, 9, 8, 7. Okay. Equal to symbol means closed dots. Greater than means it's going to the right. Okay. And I just want to make a little reminder. The reason why we put a closed dot instead of an open dot is it represents that 9 is part of our answers for x. X is greater than or equal to 9. So this graph represents our answer. All of these numbers that are greater than 9 or equal to 9 could be our value for x. Okay, so just a little reminder on that. Okay, on number 2 here, looks like we're dividing by a number, so I'm going to undo it with multiplication. Right? First thing I notice is I just multiply both sides by a negative number. That means I need to flip my inequality. I'm going to do that first. So on the left, looks like we have a negative 30. On the right, canceling, we got t. All right, just be careful. Be really tempting to maybe put this on your graph and say, all right, that's greater than sign. Our arrow is going to the right. No, we need to make sure this is reading left to right. So this is t on the left, negative 30 on the right, which means we then have to flip our inequality again. Right? So there's our number line, negative 30 here. All right, as the numbers get bigger, negative 29, negative 28. As the numbers get smaller, negative 31, negative 32. All right, looks like no equal to symbol. So that means open circle. Oops, let me make it red. And it is a less than, so that means we're going to the left. All right, so that's kind of that, guys. That was just a little primer on when to flip inequalities. You guys will see as we get deeper into these, the inequality is going to kind of flip flop back and forth as we make our way through the problem. So knowing these fundamentals is really important. All right, so I'll see you guys in class. Bye.